Hi, I'm Nathan, and I tutor algebra, statistics, calculus, and data science with R. I've taught 9 years at university, and we love to help high school, university, and graduate students meet and exceed their math goals, not just learn what they need to get a grade, but to actually master the material and be successful in their next class and in the future. What I'd like to do today is compare several different factoring methods on the same quadratic polynomial. There are many methods, and the reason I'd like to compare is to help you can identify for yourself what method you actually might prefer that's easier for you to remember or makes more sense to you. Okay. We don't fix everything in our house with just a hammer. It's useful to learn different tools for different situations. Okay, so what we'd like to do is factor negative 27x squared plus 36xy minus 12y squared. So I'm going to do a factorization table. This is like a sandbox. This allows us to explore, look, and identify two numbers that multiply to a times c, which is 36. And we have to do a times c because a is not equal to 1. It's 9. And the same two numbers also have to add to negative 12. So our first method is going to be factored by grouping. And so this is a standard method. I feel its big pitfall is remembering to deal with a negative. Okay. We can use the box method. Again, we're going to use the table, split this into 4 terms from 3. We write the 4 terms like this in the box. We just look at the first column and see what they share. Well, 9 and 6 share a 3, x squared and xy share an x. So this column, a 3x is its greatest common factor. This column, the leading term is negative, and 6, 4 share a 2. They also share a y and a y. So we're going to factor out a negative 2y. Repeat the process for each row. If you notice, the 2 on the top make a quantity, the 2 on the left make a quantity. That's right here. And then you can write them with the square on the outside if you like. Both these last 2 lines are equivalent. They mean the same thing. Don't forget orphan Annie with the negative 3 out front. I like this. It's easier to see and break down in our mind, and less danger with the negative. Still a little bit, but I feel this is easier to navigate than the factor by grouping method. I love no fuss factoring. We don't have to worry about a negative in the middle term. We're still going to split it up, okay? But the first thing we actually do is we identify the term after we remove the negative 3. We identify the leading variable and coefficient, but we don't use the square. So it's a 9x. So I'm going to write down a 9x and a 9x. Then I write down what we got from the table, minus xy minus xy. We do know that when we FOIL or check our answer, we're going to need a y times a y to get a y squared. So we don't want those x's in there. So we're just going to cross those out, which is okay. And we also know we want a 9 times, we have a 9 times a 9, which is 81, and not 9. We fix that by dividing each group or quantity by its own greatest common factor. So 9 and 6 share 3. This is the exact same. So this simplifies into this, and we have the exact same result as before. You don't have to worry about having negative values from our factorization table. And this is much safer and is faster. We just need to remember to start with this step here. You'll very rarely see this when you're using this kind of method, and make sure you divide by the greatest common factor. Okay, let's look at our factorization table that we made. We noticed that the 2 terms we used are actually exactly the same. seeing in our factorization table that we have two values of the same that we used. Hence, this might be a possible perfect square trinomial. Not everything is a perfect square trinomial, but if you have a trinomial and you have large coefficients, it's worth checking to see if the first and last things are something squared or something multiplying by itself equals those, because if they are, you can do this very quickly and much faster than the other methods. The next fastest method that we did was the no-fuss factoring. We do a lot of factoring in algebra, and you are going to see it in calculus again. So it is important to be comfortable with more than one method to save ourselves time later. Please reach out to us. We love to help. We have weekday, week morning, week afternoon, week evening availability, and Saturday availability, and we love to help. Hope you have a good day and look forward to hearing from you.